Hello, Michael. Welcome to the Power Pulse podcast. It's lovely to have you here. How are you today?
Hello, Barbara. Thanks a lot for having me. I'm great. How are you doing?
Pleasure. I've been trying to get you to come to the podcast for a while now, haven't I? It's been a few, maybe going on a year now, I think.
Yeah, last time I escaped on a business trip, this time I had no excuse.
You're here. Good. Thank you so much for making the time to come and speak with us. We always start each episode by talking a little bit about something that our guests do outside of work. And my team tell me that you're into K-drama. Now, I've heard of K-pop. I haven't heard of K-drama. What is K-drama?
I don't know what your team is telling you. I watched one show, one K-drama show.
So you're not a K-drama fan then?
For me, actually, it's a very new addition to the, let's say, after-work portfolio. But it's basically a class of drama
soap
shows
opera.
from South Korea.
Okay.
Soap opera. I was traveling in Switzerland with my partner, and we were walking along a lake in Iselwald. And this is a very famous location, one of the K-dramas. And we didn't know. Oh. But we noticed there were a lot of tourists taking pictures there. And
is that how you go into it?
Yeah, and so we investigated a little bit what it is and then actually started watching one of the shows.
Very cool. But we are here today to talk about standardization in SF₆-free switchgear. We have talked about SF₆ and alternatives at length throughout the podcast episodes that we've released. SF₆ has been the go-to insulation medium for switchgear for decades. And now we've got this alternative. So we've got companies like ours looking at alternatives that are eco-efficient to replace the most potent greenhouse gas known to man. So why now? And why do SF₆-free gases need to be standardized?
Yes, I think it's a very good point in time now for standardization, because the development and implementation of SF₆ alternatives has been a focus for the R&D of the big manufacturers over the last decade, I would say. And first, there were like really open development. I mean, everyone tried to figure out the best solution, and also different manufacturers, different institutions came up with different solutions to that. And there were always also pioneers that went ahead without standardization, trying out if it works, so to say. And so there was a bit more of an exploratory phase. But now we are really in this phase where this is actually becoming the standard, where it is becoming the main procurement choice, at least in certain regions in the world, to buy SF₆-free equipment. And then it is really important to have standardization to ensure the interoperability of the equipment, to ensure that this equipment, which will be in service for 40, 50 years in the grid, that it can be serviced in this time, that people can be trained on it, and that specification for components, for the gases themselves, are somehow transferable between different manufacturers, between different grid operators.
Okay, but there are different solutions on offer. So I guess the standardization for different solutions will be different. How do each compare, and do they have strengths and weaknesses? Can you tell us a bit more about it?
Yes, that's a very good point. I mean, the standardization is more about giving a framework, a common framework, but it doesn't necessarily mean that everyone has to have exactly the same solution. Even before we came to the SF₆ alternatives, there were different technical solutions out there. So there are predominantly SF₆ now, but there are still some old oil breakers or air blast breakers out there in operation. And even with SF₆, each manufacturer uses a different filling pressure. Some have 3 conductors in the same enclosure, some have 1 there. So it's not about standardizing the design. It's about standardizing the requirements, basically, and the testing of it.
Okay. So if you've got a new piece of kit and you want to get it onto the market, so the way that you have to pass certain tests in order for it to be able to be marketed. And those tests are the same for whatever company is putting them forward. That's what you're saying.
Exactly.
So we can all be different. We have different specs, but we abide by a common set of rules.
Exactly. Because in the end, the high voltage products have to perform in the grid. They will be stressed from the grid side, basically. Yeah. And it is important that this is defined in a way. But it's not important to standardize how the equipment looks like or how it's designed. It's even better to leave that open.
Okay, it's even better.
Yes, it promotes competition and the search for the best technical solution. And I think that is something that everyone profits in the end from.
Yeah, of course. Would the energy industry suffer if there were not to be a standard approach?
So if there's like gaps in standardization or a lack of standardization, it creates kind of a bit of an uncertainty. because people are not exactly sure how to specify or what are the exact requirements. And while this might not be an issue for maybe someone who's very much a pioneer and wants to try out new things, it is kind of a barrier for the large-scale adoption. And the reason for this is these high-voltage products, high-voltage switchgear, they are typically in operation 40 to 50 years, so for basically more than a working lifetime generation. Mm-hmm. And then it's important that beyond just having the equipment, there is like an ecosystem around these equipments, for example, for the gas, for the equipment to handle the gas, to fill it in, to analyze it, to evacuate it. Also common standards for training of the people, common procedures. And there it is very important to have the standardization and create that certainty and that framework for the operators to adopt the technology.
Okay. And I guess the safety procedures that come with it must be very stringent.
Yes, safety is an absolute priority. I mean, one thing, of course, in the high voltage products, you have conductors that are at high voltage, at the high potential, and this voltage is so high that it is a very strong hazard if someone would touch it or even just come near it. So the products must be very safe in containing this high voltage. But also, if we talk about gas-insulated equipment, these are essentially pressure vessels with rather large volume of even a few cubic meters, with pressures of 10 bar, for example. And there's a lot of physical energy stored in such a pressure vessel. So when people fill the gas into this equipment, when they open it for inspection, there need to be very stringent safety procedures.
My next question has to be, who sets these standards? Who are the companies, the organizations or associations, whoever they might be, setting these standards for the industry?
So this is also kind of a longer process. So typically when something new is developed, there is maybe like a pre-standardization phase. So before there's a standardization where there's the development, but there's also kind of publication. So maybe companies or academic institutions do technical publications sharing what they are investigating and what they find out. And then there is pre-standardization activities. For example, SIGRE is a big organization that does that.
SIGRE stands for, just for our listeners?
So that's actually, SIGRE is a French abbreviation for Conseil International de Réseau Grand Électrique.
Oh, très bien.
And it stands for International Council of Large Electrical Networks. Mm-hmm. And it's a community with know-how of the power system. And one of the main outputs of this is technical brochures on topics, and this is more or less a collection of the state of the art of a certain topic. For example, SF₆ alternatives.
Okay, so this pre-standardization phase, how long does it take, and how long do you need to have something in the making before it gets pre-standardized, and how long then to be standardized?
Well, that's a very good question. I would guess that each of these phases is maybe around 5 years. Sometimes
5 years,
can also be a bit longer, especially if you really have some basic investigation, trying out different things. But maybe 5 years per phase. So that's a good estimate.
Okay. So you've told me about SIGRE. I know as well there's IEC and IEEE.
Yes. This is then IEC is the International Electrotechnical Commission, and IEEE is the Institution of Electrical and Electronic Engineers. This is a bit more US or America focused. They really then make the standards. And these standards are a good guideline for the grid operators, basically to specify equipment. What do we actually want? What are the ratings that we want? It is also very important for us as manufacturers to what do we actually design? What is the performance our equipment has to deliver? But it's also an important guideline for the testing laboratories who do the qualification of this equipment, the qualification tests, to see what they actually need to test, how the parameters have to look like when testing those equipment.
Okay. And utilities, regulators, manufacturers, I guess they collaborate, they come together into these associations and they give their 2 cents. They try and explain what their needs are.
Yes.
So that we as suppliers can give them what they want, what they need.
Yes, this coming together of the different perspectives is extremely important because the whole ecosystem has to work together, and it's important that all the perspectives are included. So you need to specify it in a way that it fulfills the requirements of the power grid. But it also needs to be something that actually can be manufactured so that we as equipment manufacturer can produce. And it also needs to be somehow provable or testable by the testing labs, because especially for high voltage products, it's an industry where the qualification and the testing is extremely important. So basically everything that needs to be fulfilled later on in the power grid also needs to be tested.
The grid is very different worldwide, right? You have different requirements in North America than you do in Europe. Yes. How does this account for all those little intricacies of the grid?
Yes. That's a very, very good question. Also one that I would say as a manufacturer keeps it very busy. I mean, for us, the best thing, of course, would be like one standard, and we develop for this, test for this, and we are done. But it's not like this. I mean, one really basic thing is if you look at the globe, there are many countries that have 50 hertz as the frequency of the alternating current. Here in Europe, this is predominant, and others have 60 hertz, which is a little bit faster in the US. And actually, when you look at the whole set of requirements or stresses for our equipment, some of them are more challenging with 60 hertz, and some of them are more challenging for 50 hertz. But we have a global perspective, so we want our equipment to work in both regions, so to say, or for both frequencies. So actually in the development, we already have to take into account that we need to be able to make the test duties that are hard in 60 hertz, but also the ones that are more hard in 50 hertz.
Just thought of another question I wanted to ask you, if we can go a couple of steps back, if that's okay. So you have standards for SF₆ equipment. Couldn't that be transferred over to non-SF₆ alternatives?
Actually, it's a very important point. So I would say the majority of all the standards are applicable to SF₆, but also SF₆ alternatives and also other technology like old oil breakers or vacuum circuit breakers. And this is because they just describe what are the requirements coming from the power grid and how it needs to be tested. And this should be independent of the technology, because it also enables us to try out new things, actually, new technology. There are, however, a certain set of standards that are then technology specific. And this is everything that relates to handling the gas, also a bit to the safety in doing that. It is relevant when you specify these gases that you fill in. You want a common specification so that also suppliers that provide, for example, gases can orient themselves to fulfill these specifications and sell to different parties. And also some specifics in testing, for example, when it comes to gas tightness or to leakage testing. This is an important topic. We want the gas to stay in the equipment. And there the requirements can be a little bit different from a gas that has a very high climate impact like SF₆ to the non-SF₆ gases who have a way lower environmental impact when they leak out.
One global SF₆-free standard, is it attainable? Is it needed?
I think there cannot be one global standard. There's already today a very diverse standardization landscape. And I think most of it has already been updated to account for the SF₆ alternatives. So we see this, the grid operators, we as manufacturers, we have the tools in hand to provide the equipment, SF₆-free equipment for large-scale adoption in the power grid. And I think what we can do going forward and what's important is this return of experience. Now this equipment is being used in the grid. We collect the hands-on experience. And it's important to use then the pre-standardization work, the standardization work, forums like SIGRE to give this return of experience and induce this in a continuous improvement of standardization.
Okay. So in your view, what does the SF₆-free grid look like in the future? For years to come? Yeah.
For me, the big wish is that SF₆-free equipment becomes basically the standard choice whenever the rating desired by the operator is available. That the operators really have the certainty to say we go for the SF₆-free equipment. Because I think it's a beautiful thing. It enables us to extend the grid, to connect more renewables to the grid, to enable electrification of transportation, of heating and so on by strengthening the grid. And we can do that without adding tons on tons of the SF₆ that we would then have to manage for decades to come. So our vision would be that it becomes the standard to go SF₆-free.
That's the future's bright. Just before you go, I know you hold a quite important role within one of these organizations that we mentioned, SF₆-free. Can you tell us a bit more about the roles and how companies come together and how they work together to achieve a common goal?
Yes. I think SF₆-free especially is an extremely motivating collaborative approach because you have the different parties in the manufacturers. We call it users, which is essentially the utilities or the grid operators. But you also have suppliers like that provide gas handling equipment, also sometimes academia and consultants. And all of them come together to share.
Are these the working groups?
Yeah, in working groups, for example. This is a key point. I would say it forms the core somehow of the SF₆-free to have these working groups to work on those technical brochure to basically further the state of the art a little bit by providing this brochure or this state of the art in a condensed manner. And it's very interesting because you have the different perspectives, but you might also have, for example, direct competitors in such a working group. And so there's also very defined guidelines how the collaboration can be in such a working group. And basically, it relies that you can only share information that is public or intended for publication anyway. But you can, of course, not share any, let's say, confidential information or commercial information of clients or supply strategies or something like that. So there's a defined framework of how to collaborate there. But of course, this is also a motivation for all involved to actually publish information, to write technical papers and to share basically the know-how that is established with the wider community. And especially when it comes to new technologies, this is very interesting because some parties need to be the pioneers in implementing this technology in, for example, designing or testing such products. And then they actually do have this know-how because they needed to do it to bring the products to market. And then it's very good to be able to share this in such a framework and contribute to furthering the state of the art.
You are lead. I can't remember. There is a word to describe your role within one of these working groups.
I'm a convener of one of the working groups.
There we go.
Which, it is somehow a bit an organizational role, basically looking for the members of the working groups, organizing that the working group meets in regular intervals, that there's a good plan in drafting such a technical brochure, that there's also, I would say, a diversity of perspectives in the working group so that everyone can be heard. And yeah, I think this is, for me, it's a great opportunity to do that and very motivating to work in such an environment.
Are you able to share something that you're working on at the moment, or
the working
strictly confidential?
No, it's actually public. So it's the working group is about eco-design methods for the power system. So it is basically how this approach of eco-design, of considering the environmental impact of a product or a service already in designing it, how this can be applied to the power system and to the components in the power system.
Okay, that's very interesting.
It is. I can just agree. Yes, I can attest for that.
Thank you so much for coming in and talking to us about such an interesting topic. It's been wonderful having you here. Thank you.
Thanks a lot for having me, Barbara.
It's been worth the wait. Thanks, Michael.
Thank you, Barbara.